When we look up at the night sky, it feels endless. The darkness above us seems to stretch forever, punctuated by small points of light that barely hint at their true distance. Tonight, we are going to gently explore how far the universe goes, how large it truly is, and what science currently understands about its size, its boundaries, and the mysteries that may lie beyond. This is not a story meant to rush. There is nowhere we need to arrive quickly. Only a quiet journey outward. Let us begin close to home. We start on Earth, a small planet orbiting an average star we call the Sun. Light from the Sun takes about 8 minutes to reach us. Already, we are speaking in distances measured by time. Astronomers often describe the universe using light years. A light year is not a measure of time, but of distance. It is how far light travels in 1 year, and light, even at its incredible speed, still needs time to cross space. Our nearest neighboring star, Proxima Centauri, is just over 4 light years away. That means the light we see from it tonight left that star more than 4 years ago. Already, we are looking into the past. As we move outward, we encounter stars, nebula, and vast clouds of gas and dust. Our galaxy, the Milky Way, contains somewhere between 100 and 400 billion stars. From one side to the other, the Milky Way spans about 100,000 light years. If you could travel at the speed of light, it would still take 100,000 years to cross it. And yet, our galaxy is only one among hundreds of billions. Beyond the Milky Way lie other galaxies, each its own island of stars. The nearest large galaxy, Andromeda, is about 2.5 million light-years away. The light reaching your eyes tonight from Andromeda began its journey before humans walked the Earth. As telescopes improved, astronomers realized that galaxies were not evenly scattered. They form clusters and superclusters woven together by vast filaments of matter. Between these filaments are enormous voids, regions of space, with very little inside. This large-scale structure is sometimes called the cosmic web. It is the largest pattern we have ever observed. And yet, even this is not the full universe, because there is a limit to how far we can see. This limit is called the observable universe. The observable universe is not the entire universe. It is simply the portion from which light has had enough time to reach us. Since the beginning of cosmic expansion, the universe is about 13.8 billion years old, but the observable universe is about 93 billion light-years across. This seems impossible at first. How can something be older than its own diameter? The answer lies in expansion. Space itself is stretching. Galaxies are not simply moving through space. Space is expanding between them. This means that light traveling toward us must cross ever-growing distances. The farther away something is, the faster it appears to be moving away. This discovery was made in the 1920s by Edwin Hubble, and it changed everything. The universe was not static. It was expanding. If we reverse this expansion backward in time, everything comes closer together. This leads us to the Big Bang. The Big Bang was not an explosion in space. It was an expansion of space itself. At the earliest moments, the universe was incredibly hot and dense. As it expanded, it cooled. Matter formed, atoms formed, stars formed, galaxies formed, and still, the expansion continues. Astronomers made another discovery. The expansion of the universe is accelerating. Something unknown is pushing space apart faster and faster. We call this dark energy. Dark energy makes up about 68% of the total energy content of the universe. We do not know what it is. We only know what it does. Because of dark energy, there are regions of the universe that are already beyond our reach. Light emitted from those regions today will never reach us. They are moving away too fast. This creates a kind of cosmic horizon. Beyond it, the universe may continue endlessly, or it may curve back on itself. Science currently allows three main possibilities. The universe may be flat, meaning it extends infinitely, in all directions. It may be closed, like the surface of a sphere, finite but without an edge. Or it may be open, expanding forever, with a subtle curvature. Measurements of the cosmic microwave background, the faint afterglow of the early universe, suggest that space is very nearly flat. This points toward an infinite universe. But infinity is difficult to prove. There may be regions beyond the observable universe that look nothing like our own. Some theories suggest our universe is only one among many. This idea is known as the multiverse. In some versions, different universes may have different physical laws. In others, they may simply be far beyond what we can ever observe. These ideas remain speculative. Science requires evidence, and for now, our evidence ends at the edge of the observable universe. Still, even what we can observe is vast beyond comprehension. Every point of light in the sky is a story billions of years old. Every photon reaching your eyes has traveled unimaginable distances to arrive here. Now, as you rest, it is okay not to understand everything. The universe does not demand that we grasp its full size, only that we remain curious, only that we wonder. And as space continues to expand and galaxies drift farther apart, we remain here, tiny, aware, and capable of asking questions, and sometimes quietly listening. And so, as we continue outward in thought, we begin to notice something subtle. The farther we look into space, the farther back in time we are seeing. This is not poetry. It is physics. Because light takes time to travel, distance and history are the same thing. On cosmic scales, when astronomers observe galaxies billions of light years away, they are not seeing them as they are now. They are seeing them as they were billions of years ago. Young galaxies, hotter galaxies, less organized. In this way, the universe itself becomes a record, a slow glowing archive of its own past. At the very edge of what we can observe, we encounter a faint, nearly uniform glow coming from all directions. This light is called the cosmic microwave background. It is the oldest light we can see. It was released about 380,000 years after the Big Bang, when the universe cooled enough for atoms to form and light to travel freely. Before this moment, the universe was opaque. Light could not move far without being scattered. The cosmic microwave background is like a photograph of the universe as a baby. Tiny fluctuations in this light represent the earliest seeds of all structure we see today. Galaxies, clusters, and superclusters all grew from these small variations. By studying this ancient light, scientists have measured the age of the universe, its composition, and its geometry. These measurements tell us that ordinary matter, the kind that makes stars, planets, and people, accounts for only about 5% of the universe. The rest is invisible. About 27% is dark matter. Dark matter does not emit light, absorb light, or reflect light, but it has gravity. We know it exists because galaxies rotate too quickly to be held together by visible matter alone. dark matter acts like an unseen scaffold, holding galaxies and clusters together across vast distances. Without dark matter, the universe would look very different. Galaxies might never have formed at all. And then there is dark energy, the mysterious force, driving accelerated expansion. As space expands faster and faster, the distances between distant galaxies grow beyond any possible connection. Over trillions of years, even nearby galaxies, outside our local group, will disappear from view. Future observers, if they exist, may see a much smaller universe, not because it shrank, but because the rest moved away. This reminds us of something important. The size of the universe is not just a number. It depends on time. It depends on motion. It depends on the limits of what can be observed. When we say the observable universe is about 93 billion light-years across, we are describing a sphere centered on us. But this does not mean we are special. Every observer, anywhere in the universe, has their own observable universe, each centered on themselves. This tells us something profound. There is no true center of the universe. Expansion happens everywhere. Space is not expanding into something. It is expanding as everything. If the universe is infinite, it has always been infinite. The Big Bang did not create space at a point. It created expansion everywhere at once. If the universe is finite, it has no edge, no boundary you could reach, just as you can walk forever on the surface of Earth. Without encountering an edge, space could curve back on itself in higher dimensions. These ideas are difficult to picture, and that is okay. The universe does not require that we visualize it perfectly, only that we describe it carefully. One theory suggests that shortly after the Big Bang, the universe underwent a brief but extreme period of expansion. This is called cosmic inflation. During inflation, space expanded faster than the speed of light. This does not violate relativity, because it was space itself expanding, not objects moving through space. Inflation helps explain why the universe looks so uniform, why it is so flat, and why distant regions share similar properties. If inflation occurred, then the universe beyond our observable horizon could be unimaginably vast, possibly infinite, possibly containing regions that look almost identical to our own. In an infinite universe, every possible arrangement of matter occurs somewhere, not because it must, but because infinity allows it. There could be regions where galaxies are arranged differently, regions where history unfolded another way. This idea is unsettling to some, comforting to others. Science treats it cautiously. Infinity is a mathematical concept. Nature may or may not use it. For now, we measure what we can. We test what we can observe. And we remain humble about what lies beyond. As you listen now, you can allow the scale of the universe to soften your thoughts. Problems shrink when measured against billions of light years. Urgency fades when time stretches across cosmic ages. The universe has been here for nearly 14 billion years, and it will continue long after stars fade and galaxies drift apart. Some theories predict a slow heat death where energy spreads evenly and no work can be done. Others suggest new phases of physics we do not yet understand. But for now, the universe is rich, structured, and full of light. And here you are, listening quietly, connected to it all, not by distance, but by understanding, by curiosity, by the simple fact that atoms in your body were once forged in ancient stars. You are not separate from the universe. You are one of the ways it becomes aware of itself. And as the universe expands, as space stretches gently outward, You can let your thoughts do the opposite. You can let them settle, slowly, naturally, resting within a cosmos that is vast, lawful, and calm.